Alright, welcome back to the new year. Let's hope it's better than the last one, eh? Today we're reading about applicative functors. Oh shit, I don't even remember what functors are. Were they for creating functions? I don't remember. Haskell's combination of purity, higher order functions, parameterized algebraic data types, and type classes makes implementing polymorphism much easier than in other languages. Right, a functor is a function that is like a... Was it like a curried function where it's not a... No, that's not a functor either. I suppose it is a function that is an intermediate function that is applied where you use a function as the parameter in the function, maybe. We don't need to think about types belonging to a big hierarchy. Instead, we consider what the types can act like and then connect them with the appropriate type classes. An int can act like a lot of things. An equatable thing, an ordered thing, an enumerable thing, and so on. Type classes are open, which means that we can define our own data type, think about what it can act like, and connect it with the type classes that define its behaviors. We can also introduce a new type of class and then make already existing types an instance of it. Because of that, and because Haskell's type system allows us to know a lot about a function just by its type declaration, we can define type classes that define very general and abstract behavior. We've talked about type classes that define operations for seeing if two things are equal and comparing two things by some ordering. These are very abstract and elegant behaviors, although we don't think of them as very special since we've been dealing with them for most of our lives. Our lives? I mean, I don't know about that. Oh. Right. We've been dealing with them as... Right, it's part of how we think as humans, but computers, implementing it like that for computers. That's why we're talking about the abstraction. Right, chapter 7 introduced functors, which are types whose values can be mapped over. Oh, that was a functor. That is an example of a useful and yet still pretty abstract property of that type classes can describe. Right, so a functor, that was a box, right, where we map over things. There are things like lists or trees or what are called maybes, right? You can map over the just and the nothing, right? Potentially, yeah, functors are like boxes in a sense that can contain different types of values. In this chapter, we'll take a closer look at functors, along with slightly stronger and more useful versions of functors called applicative functors. All right. Functors redux. Oh, nice. Good. As you learned in chapter 7, functors are things that can be mapped over. Yep. Like lists, maybes, and trees. Oh. I mean, am I awesome or what? That was exactly the examples I gave, wasn't it? Lists, maybes, and trees? I think that's what I gave. Right, in Haskell, they're described by the type class functor, which has only one type class method, Fmap, right? Fmap was as a type of Fmap. We take a function, takes an A and returns a B. Then we apply the function to A and the function to B. Right. Which says, give me a function that takes an A and returns a B. And a box with an A or several of them inside. And I'll give you a box with a B. Oh, right. Right, exactly. Give me... Yeah, because it doesn't have to be a list, it's just an A. Because the A is a list, a maybe, or a tree here. No? Give me a box with an A, yeah, or several of them inside it, and I'll give you a box with B or several of them inside it. It applies the function to the element inside of the box. Right, that's the F. Confuses me a little bit here. F kind of represents the function and the box in itself, right? A list is kind of a function, right? Where we add things to the list or whatever. Yeah. It applies the function to the element inside the box, indeed. We can also look at functor values as values with an added context. Oh, I like that. Functor values as values with an added context. Kinda like that. Oh, hello Mike Craftchick. Nice to see you again. How are you doing today? How is your oxygen not included going? Right, for instance, maybe values have the extra context that they might have failed. Context. With lists, the context is that the value can actually be several values at once or none. Yeah, we have multiple values. Fmap applies a function to the value while preserving its context. Kind of like that. So a functor are things that can be mapped over. So functors are context pretty much, right? No, they are stuff and the context. Yeah, they are both. The functor can be any value, but the context is what is important. Oh yeah, Happy New Year, by the way, Mike Kravchik. I'm dying after a party that started yesterday and ended 30 minutes ago. Oh, that sounds like... I'm assuming that the party didn't start yesterday. I think you've been partying for a full, like, over an entire year, haven't you, Mike Kravchik? Started partying last year and you partied to this year. Oof, that's a big party, dude. Hope you had a good time, yeah. If we want to make a type constructor of an instance of functor, it must have a kind of... Right, kind. Shit, we read that a couple of weeks ago. That was a layer of abstraction, right? It takes one thing and returns another thing. That's the type is our... That's our... Oh, right, our type constructor, right? Yeah. If we want to make a type constructor, an instance of functor, it must have a kind of something and return something else, which means that it takes exactly one concrete type as type parameter. Right, that was what it was called, a concrete type. That was important because not all the type constructors take concrete types. For example, maybe can be made an instance because it takes one type parameter and produces a concrete type, like maybe int or maybe string. If a type constructor takes two parameters, like either, we need to partially apply, right? That's it. The curried function. We need to partially apply the type constructor until it takes only one type parameter. So we can't write an instance functor either. Right, we can't write instance functor either, but we can write instance functor either a, right? Because we have to return a concrete type, and that's the thing where we're missing. Where? Then if we imagine that Fmap is only for either a, it would have this type declaration. Okay. Fmap would have B to C either AB or either AC. Yeah, exactly, where A... We apply the function to B or we apply the function to C, but we keep the context A. There we go. What do we have here? Oh, nice. Gotta go fast. Man, this was some time ago. Need for Speed Most Wanted. Oh yeah, I played this game. I don't know about Black Edition, but I played this game. Wait, did you say this was available for free right now? Archive.org or something? Do we have like a wholesome? That is for memories, right? Yeah. Wholesome good times. Oh shit, my balance is all... I'm all out of balance. I gotta stop giving awards away. Look at those graphics. Graphics, even. Yeah. Good time graphics. Zoom in a little bit. Actually, it's looking way better than I thought it would look. Oh, that's... Here we are. As you can see, the either A part is fixed because either A only takes one type parameter. Either A only takes one parameter, and that's the parameter that we're changing. NodeOwner says, I installed this in Flatpak Steam as a non-Steam game, even with the CDs. Very nice, very nice. Then we can have IO actions as functors. Right. You've learned how a lot of types, well, type constructors really are instances of functor, and then lists, and maybe either a, as well as tree type, a tree type that we created in chapter 7. You saw how you can map functions over them for great good. Now let's take a look at the IO instance. We're back looking outside in the actual world, eh? If some value has a type of, say, IO string, that means it is an IO action that will go out into the real world and get some string for us, which it will then yield as a result. We can use this little icon, the less than dash sign. It's the arrow to the left. We can use the arrow to the left syntax to do, oh, bind. That's what it was called. Yeah, we can do the bind to a result to a name. That would do the IO action, and we bind it to a string. So what we would have would be a string from here. Right, in chapter 8 we talked about how IO actions are like boxes with little feet that go out and fetch some value from the outside world for us. Yeah, that's the IO string. Is an IO action that collects a string that we bind to an actual string so we can do functional stuff with it. There we go. There's no preview available for this item. Alright, here we go. It's in the Internet Archive.org. Archive.org/details Need for Speed Most Wanted Black Edition USA. Right. Please download the files. Yeah, they're actually here. No reviews. Need for Speed Most Wanted Black Edition USA. Nice. It's... I kind of like this way of providing a free game. It's like super free when it's in the Internet Archive, isn't it? Compared to other places to get free games, I suppose. Right. Where were we? Alright, we bind it to the outside world. We can inspect what they fetched, but after inspecting we need to wrap the value back in IO. Considering this box with feet analogy, you can see how IO acts like a functor. Does it? Oh yeah, because we're talking about boxes. Hello, Colgate on tap. Nice to see you again. How are you doing today? Well, the inspiration for today, for the new year, mind you, yeah. This year we're gonna keep reminding ourselves that you are well liked. Oof, that's quite an awful thing to feel that you need to remind yourself about, isn't it? Being well liked. That kind of implies to me, if you need to keep reminding yourself that you are well liked, that kind of implies to me that you are not. Maybe? Maybe not, however. No, actually, let's flip that around. If you're in a deep depression, you have a skewed view of reality, right? And you see yourself as worth less. Not that you're lesser worth, but you're worthless, like you're worth nothing and nobody likes you. And in that situation, right, if you're in a severe depression, it might be a good idea to keep reminding yourself that you are well liked. There are people who like you. Yeah. Right? To remind yourself that the depression thoughts are just that. They are skewing your perception of reality, and it is not real, if you will. Well, Node Runner is joinking the first. Alright, how was your New Year's Eve, Colgate on tap? Alright, we were just talking about a functor. Right, yeah, we were talking about boxes. We had box analogies. The functor was a box with a value in it. And so is an IO action. It's an action with a value in it. So they are very similar. Yeah, it acts like a functor. It kind of does, yeah. I was kind of hesitant of using the box analogy before when we were talking about analogies. We were talking about lists and stuff, because it's like, oh man, I'm gonna get confused with IO actions and functors, but no, that is actually, they are very similar. or they act like a functor. That's nice. Noteowner says, I mean, lots of stuff is in that Internet Archive. They have some kind of copyright shield. That is great stuff. Yeah, the Internet Archive. Good stuff indeed. Colgate on Tap says that the New Year's Eve, it went. Nothing special. Yeah, I was watching TV. I ate some good food. Yeah, I met with the family and ate some good food. That was it. We were actually, it was quite funny. We were watching a movie last night when the time switched over to 12 o'clock. Usually we go out and watch the fireworks that we don't shoot our own. Well, I haven't shot my own fireworks in a long time. Long time. But, yeah, was with my parents and we were watching a movie and the movie was just getting really exciting and we were like, this is great timing. We're gonna go out and watch the fireworks. We were watching it on TV, so there was no pause button on the movie. Like the olden days. My parents are old. Right, so then we just decided to stay indoors and just watch the movie instead because it was exciting. Didn't even go out. We didn't do anything special at all. Just keeping watching the movie. Noteowner says, I don't pretend to understand it. I'm not a lawyer. Me neither. I'm not a lawyer either. Alright, let's see how I/O is an instance of functor. Oh, it is. When we fmap a functor over an I/O action, we want to get back an I/O action that does the same thing but has our function applied over its result value. Here's the code. Alright, let's look at the code. Right, instance functor I/O where we do fmap the function on our action. We're gonna bind the result of our action and then we're gonna return function on the result. Yeah, right. We're mapping our, that's our context, right? We're mapping our function over the result while the action is the box. Right, and we return an I/O action. Is that what's happening? When we fmap over a function, when we fmap a function over an I/O action, we want to get back an I/O action. Yeah, that's what we're doing. That does the same thing, but has our function applied over its result value. Here's the code. Exactly, because we're doing a do thing. We're returning another I/O action because the context is being preserved. We just call our function on our values within the context. Right. The result of mapping something over an I/O action will be an I/O action. So right off the bat, we use the do syntax to glue two actions and make a new one. In the implementation for fmap, we make a new I/O action that first performs the original I/O action and calls its result. Yeah. Well, the fonts are a little bit off, right? We see that they are different fonts right here, but it's not super clear. Right. Then we do return function and result. Yeah. Recall that return is a function that makes an IO action that doesn't do anything but only yields something as its result. Makes an IO action that doesn't do anything. Oh. I remember our actions that didn't do anything, right? Our null actions, if you will. Just to pass around values. Or... Alright. Yields. So wait, we don't get back an action? Well, this is our action. So maybe we only have the result? The action that the do block produces will always yield the result value of its last action. That's why we use return to make an IO action that doesn't really do anything. Just yields. Alright, that it yields f result as the result of the new IO action. Check out this piece of code. It kind of... It's like print. Print is, it does the same, right? Print has a return value as well, where it's just an empty tuple, right? Which is like a null return thing. Think. Right. Main. Do line. Yeah, do that line. Oh, that makes me think of Dr. Roxo, the rock and roll clown. Do that line. I do cocaine. What he says. Right. Let wait. Let line be reverse line. Okay. Then we're gonna put the string you said plus plus line backwards. Right, it's gonna print backwards, right? Wait. Oh, no. Do line is get... Right. We're getting a line. Right, that's our IO action. I got confused. That's our IO action, so we got a string here. And we're gonna do a new line, which is gonna be the reversed line. So then you said, and then we're gonna print, or we're gonna join this string together with our reversed line backwards. Then we're gonna put the string, yes, you said... Wait, why does this matter? Why do we do it 2 times? These would be the same, right? This line here would be printed backwards both of the times, right? I think so. Hello, just wait. Just to Sophie? Oh man. I'm sorry if I butchered that name. Happy New Year. How are you doing this new year? Pointfree.io, what's this? Sorry for the hard name, lol. Oh, it's fine. I mean, it could be just to Sophie, or it could be just oh Sophie. I mean, there are many different ways to check it out, isn't it? Convert Haskell code into point-free Haskell code. Pointfree.io, nice. Why would we want to do point-free Haskell? And what is? Got sidetracked, didn't we? Yeah. Happy New Year, says just to Sophie. Thank you. It can convert Lisp Haskell into pretty Haskell. That's what we do. All right. Point free. We actually add points. All right. This is the point free style, and this is, yeah. More people that don't like Lisp, eh? I would have guessed it was the other way around. Just as Sophie says, pointful. Yeah. Full of points. Rather than point free. Right. Shit, I lost track. The user is prompted for a line which we gave back but reversed. Here's how to write this by using Fmap. Main do line is gonna Fmap reverse on get line. So our line will be reversed. Right, we're mapping reverse. Oh, that is confusing. Right. Why I got confused is like, wait, how do we reverse the characters in a string? But that's not what we have. We have an action with the string. And we're mapping reverse on that action, not on the string. So that is why we get the flipped string, well, the reversed string rather than the trying to reverse the characters, because the list of characters, the list is not the context that we are preserving. It's the action that we are preserving. Well, Getino Tab says, I got it confused by point free name as well. Yeah. Bad name, right? Yeah, it kind of seems like you would remove the function compositions in favor of parentheses, making it into Lisp rather than away from Lisp. Just as Sophie says, you map, wait, map, consider Fmap as compose here. Shit, I don't remember compose. What does compose do? I'm terrible at names. Names of functions as well. It is point free because, and then just Sophie didn't finish that sentence. Right. Here's how to write this by using Fmap. All right. Just as Sophie says that this here line is an additional variable binding, an additional point that you can eliminate. Oh, is this point free? Is that really relevant? Oh, so this... I thought that was point free. We were talking about something completely different. Right, but this... Right, yeah. This here. We don't need this. We can just do the map, right? We map the reverse on our action. Yeah, exactly. I mean, that makes sense to me. And these are just the same, yeah. Just as we can Fmap reverse over just blah to get just help, we can Fmap reverse over getLine. GetLine is an IO action. That is our context that has type of IO string, and mapping reverse over it gives us an IO action that will go out into the real world and get a line and then apply reverse to its result. In the same way, we can apply a function to something that's inside a maybe box. We can apply a function to what's inside an IO box, exactly. But it must go out into the real world to get something. Then when we bind it to a name using the bind, the name will reflect the result that already has reverse applied to it. Yeah, exactly. The line will be reversed. So it would be better to do reversed line. Instead of naming it line, we would name this reversed line or line with an apostrophe. No, is that called? I don't remember. Single quote. There we go. Single quote. Right. Just as Sophie says, have a great stream. Why, thank you. Yeah. Thanks for stopping by and yeah, have a good one. We'll get in on tab said that point-free version of count AB equal to 2 times A plus B is... Wait, is count equal to parentheses plus 0.2 multiplied. Ironically, it's more Lisp in this case. That is ironic, yeah. Right, it's because we remove the A and B. So part of the point-free style I like and part of the point-free style I don't like. Yeah, I prefer to sometimes, well, at the moment, I prefer to see the variables in our function, right? I would prefer to say count AB instead of just count equals to. But that's personal preference that if you get good at Haskell, you would probably go for the point-free way. Yeah. Right. The IO action Fmap ++ exclamation point getLine behaves just like getLine, except that the result always has the exclamation point appended to it. Exactly. If map were limited to IO, its type would be Fmap. Right, IO action. No. Yeah, exactly. But instead of IO, there is an F here because we can put anything here, not an IO. Fmap takes a function and an IO action and returns a new IO action. That's like the old one, except that the function is applied to its contained result. Exactly. If you ever find yourself binding the result of an IO action to a name, only to apply a function to that and call that something else, consider using Fmap. That is something that I'm gonna have difficulties remembering. I see the benefit of it, just remembering doing this. Because Fmap is so generalized. You can do so many things with it. Yeah. Because in my mind, right, the IO string, I would thinking that if we map on that, we would map it on the characters, not on the string. Guess I need to consider the IO. Be aware of the IO some more. Well, the Getino tab says it's like map, but cool. Very cool. If you want to apply multiple functions to some data inside a functor, you can declare your own function at the top level, make a lambda function, or ideally use a function composition. Here we go. Point-free stuff. Function compositions. Right, we can import data.char, we can import the data.list. In main, we can do our line, and we're gonna fmap intersperse the dash. But we're actually gonna map as well. All right. So we're getting our line. We're on our string. Yeah, we're mapping on our characters. We're making all the characters uppercase. No, shit. No, it's actually on our action still. Yeah. No, all of these are on the entire string, not on the characters. So reverse, we're gonna reverse the string. We're gonna intersperse. Wait. That between every, yeah, that's between every character. I was thinking it's not between the words. No, it's on every character. And we're mapping... Oh, no, actually here, the map is on the characters because we are within our Fmap. This is all done on the string, so this map happens to the character. And then this is what we go. Hello there, and we're getting... Yeah, we're doing all of those things with our composition. Fulgitunotab says, do you still find function compositions hard? I haven't worked with them at all. The reason why I find them hard is I don't know when to put the dot operator or when to put the dollar sign. But my thinking is that the ordering we do these things doesn't matter. We want to do all of these things on the string. We don't want to do one first and then the other. That's the way I understand it, but I'm not sure that is completely correct. But that's the way I understand the dot operator. Compared to the dollar operator, that makes sure that we do one thing first and then the other. I don't think that's completely correct, but that's what it looks like in my mind with the function compositions. Right. The intersperse, yeah, here we go. That function takes a string, maps to upper over it. No, it actually does that in this order. Maps to upper, then it reverses, then it... Yeah, then applies intersperse to that result. It's a prettier way of writing the following. Yeah, way prettier than the Lisp way of doing it. So we could have just used, could as well just have used dollar signs here, I guess. Yeah. Can't? Okay. Right, that's... So yeah, I still find them hard. Well, I think I didn't get the function composition, so it might be a good idea to reread the function compositions a little bit. Wow. I think that functions as functors will have to wait. I think it's lunchtime now. Yep, I think that is it. So I hope you will have a great new year. And thanks for hanging out. And see you next time. Maybe. Yeah. Cheers.